Hi all, welcome to Learn Code Repeat. Today we'll be looking at day 16 of the October LeetCode challenge. The name of the problem is search a 2D matrix. Let's look into the problem. So the problem says write an efficient algorithm that searches for a value in an m by n matrix. This matrix has the following properties. Integers in each row are sorted from left to right. The first integer of each row is greater than the last integer of the previous row. Okay, so what's given here is each elements in the row are in sorted order, and also the first element of the row is greater than the last element of the previous row. Okay, so here, right, we can simply solve this using a binary search algorithm, right? So we have given a target and we need to find that target number, right? So for example, if the number is 3, we need to find out 3, right? So here, right, if we need to find out a number, we need to first find out in which row the number may be present and then try to find out that number, right? So that means we need to first try to do a binary search on the row, because we know that all the numbers are in ascending order and the next row will have all the numbers greater than the previous row, right? So we can do a binary search and check whether the target number is less than the range of the row, right? So for example, if the target number is let's say instead of 3, right, it's 16, right? So I'll first find out the row, right? So my first step will be to get the row using binary search. Okay, so to get the row, let's say if 16 is the value, right, that I need to search for, so I'll do binary search on this column. Okay, so when I do binary search, I will divide this into mid and low and high. Then once I have the mid, I'll check for this range, right? Let's say this is the mid, right? So I'll check for this range and see whether the target is between this range, start and end value. I won't do a binary search on that row yet, but I'll just check whether the target is in this range. So once I get the row, I understand which row it is, then I'll do a binary search only on that row. It will be a normal binary search, right? So it will just be on that particular row. So I'll check again, I'll do a binary search on this particular row and check whether the target is present. Accordingly, I'll return true or false. Okay, so the output here expected is either return true or return false. So true if the number is present, false if the number is not. So this is one way, and there is one more way which is much more simpler. So first we'll check the code for this particular approach and see on what conditions this particular approach will be better than the other approach. Okay, so the skeletal code for this will be very simple. If the matrix length is 0, that means there are no elements, then return directly false. Then first call the getRow method here. Okay, and if the row is greater than or equal to 0, only then do the binary search. But if it's not able to find the row at all, then you can directly return false. So that's what I've done here. If the index I have initialized at -1 and index is greater than or equal to 0, only then return true, else return false. So here, assuming that we got the row, so once the row is greater than or equal to 0, we will do binary search for only that particular row. So matrix of row will give me only that particular single array, and I'll do binary search for the target on that. Okay, so let's see the code for get row. So this is the matrix that is passed into the get row and the target. So I'll come to this particular piece of code later on. Otherwise it's the same code of a normal binary search. So we are trying to find out the mid here. So here low will be 0, high will be length of the matrix -1, which is nothing but the row -1. So it will give me the row, right? And then I'm trying to find out the mid of that. And once I find the mid, I'll just check whether the target is in that range. That means my target should be greater than or equal to the 0th element of the mid, and target should be less than or equal to the last element of the mid row. If that is the case, then I will return mid as the row index. Else, if it is if my target is less than the 0th element, that means it has to be in the previous row, right? Somewhere in the previous rows. So I need to reduce my high, which is equal to mid -1, else I need to increase my low, which will be mid +1, and then I'll try to find out the mid and do the same binary search algorithm. Okay, now here, right, what I'm doing here is, for this example, the case is that all the rows in the matrix will be of equal length. But let's say we have a matrix, right, something like this, where we have 1 2 3, my second row is empty, my third row is 4 5 6. So basically each row the length is uneven, right? This is my matrix. Now in this case, right, what will happen is I need to find out, let's say 5, right? So if this is the mid value, I need to take care of this condition. So I can either go to the previous row or I can go to the next row to find the element, right? So that is been taken care here. So I'm trying to find out, when I get a mid, I'm trying to find out the length of the column. So if length of the column is equal to 0, right, so that is a case that is taken care here. So I can go to the previous row, right? So I need to check whether my previous row is greater than or equal to low. So that's what I'm checking here. If it is greater than or equal to low, that means if it's safe to go to the previous row, then do mid minus minus. Else if mid plus 1 is less than or equal to high, then it's safe to go to the next row. So I'm doing mid plus plus. Okay. Else I can directly assign mid equal to minus 1 and break out of the while loop. That means I didn't find any row where the target number is in the range. So I can return mid minus 1. Now this particular case can happen that the interview starts with all the columns are of equal length, and then they may give this condition and ask you to optimize the code. So in that case you can add this particular condition. Okay. And the binary search algorithm is similar to the get row method, right? The way we did binary search there, it's similar to this. So once you have the row, you can directly do the binary search on the row. So this is a typical binary search algorithm where we are checking whether the target number is found or not, and accordingly returning either the mid value, that is the index value, or return minus 1 if it's not found. Okay, I've covered binary search in detail in my previous video. You can find the link somewhere above or in the description below. So let's now look into the other approach to solving this problem, right? Now the other approach is, earlier we tried to do a binary search on the row to find the exact row, and then within the row we did one more binary search, right? The other approach is, since it's given that each number is in increasing order, right? So even in the same case, right, so 1 3 5 7, and after that the next row will always have a number which is greater than 7, right? So we can very well say that this is a single array, right? Instead of a two-dimensional array, I can directly say that it goes like this, then it goes like this, right? So we can very well convert this as a binary search in a single dimensional array. So how can we do that, right? So if I want to access this particular, let's say 11 is the number that I want to access, right? This is nothing but 1 2 3 4 5 6, and this is 0th index, right? So 6 minus 1 is 5. So this is the fifth element, right? If I am going by 0th index, right? So this is fifth element. So fifth element, if I'm having this as a index, right? So 0 1 2 3, this is 4 5 6 7 8 9 10 11, right? In total there are 11 elements, right? Since it's a 4 by 3 matrix, right, its number of rows into columns, so 4 into 3 is 12 minus 1. So minus 1 I'm doing because it's a 0th index, so in total 11 indexes are there, right? So if I want to find the fifth index, right, so what I'll do is, fifth index, if I want to convert that in two dimensional in this particular array, right, so I'll do the index, right, index divided by the number of columns, right? Number of columns is 4, so column length, index divided by column length. So this is my row, and my column will be index mod column length. This is my column. So 5 divided by 4 is 1, and 5 mod 4 is 1. So 1 comma 1 will be my row and column number in the two dimensional array. So that's what it is here, right? 1 comma 1. Okay, so this is the formula for finding out that. So using that, we can do a binary search on this particular two-dimensional array. We can consider this as a one-dimensional array and find out the target. Okay, so that's the logic. So let's see the code for this. So I've written the code here. So as I said, what we are first checking is, if the row is 0, that is the row length is 0, return false. If the column length is 0, return false. We can directly do that. Then I am directly multiplying row into column minus 1. So I am getting the low value as 0, high value as row into column, that is the total number of elements. Since it's 0 index, I am minusing 1. And then I am doing a normal binary search, right? Mid equal to low plus high minus low by 2. And to get the value, as I said earlier, Mid divide by col will give me the row, and mid mod col will give me the column number, right? Mid is the index here, and then I can directly check if that value for that particular 2D matrix array is equal to the target. If it is, then return true, else I'll do the normal binary search operation. If value is less than target, then low should be mid plus 1, else high equal to mid minus 1. This particular case is normal binary search algorithm, right? So this is a simple way of doing it. So let's submit this code and see whether it works fine. Yeah, and the code is accepted. So hope you like this video. Do hit the like button and subscribe to this channel for future such videos. Thank you.